Hey students, in this video we're going to go through section 5.1 about algebraic expressions. Our learning target is I can evaluate algebraic expressions given values of their variables. So our vocab says an algebraic expression is an expression that may contain numbers, operations, and one or more variables. By the way, an expression has no equal sign. Equations do, expressions do not. Now, what is a variable? A variable is a symbol. In our case, it's going to be a letter that represents one or more numbers. So when you see like X or Y or P, when you see a letter in math, that is called a variable, and it can represent one number sometimes, or it could represent multiple numbers sometimes. Each number or variable by itself or product of numbers and variables in an algebraic expression is called a term. So these terms are the building blocks that create our expression. They're the different pieces that are added together or subtracted from each other, either way. That could be a number by itself, like 4, a variable by itself, like if that just was P all by itself, that would be another building block, another term, or the product of numbers and variables, like that right there, 5P, that represents 5 being multiplied by P. When the number is touching the variable, it means they're multiplied. That is a term itself as well. So these terms are the different building blocks, the pieces that are being added together. The variable is whatever letters we have in there, in this case P, that represents an unknown number. We also have two other vocab terms. We have a coefficient. A coefficient is a number that comes in front of and is touching a variable. It tells you how many of this thing you have. This means we have 5 P's, 5 times whatever number P is. So when there's a number touching a variable, it means they're multiplied, and it is called a coefficient. It's coefficient. We also have a constant, and a constant is a term that has no variable attached. So whenever we have a building block, a term that is just a number like 4, that is called a constant because its value remains constant. This value could change depending on what P is. This one cannot. It will always be 4. So terms are the building blocks. A building block, a term that has no variable, is called a constant. If we have a term that includes a letter, that letter is called a variable. If we have a term that includes both a number and a variable, that number in front of the variable is called a coefficient, and it is multiplied by the variable. I know that's kind of a lot to remember, but I think seeing some examples will help us remember it a little bit better. So we're going to start with identifying terms, coefficients, and constants in each expression. So for this one, identifying the terms, this is the building blocks, the pieces being added together. There's just two things being added together, 5x and 13. So those are the two terms, 5x and 13. 5 and x are not separate terms because they're not being added together. They are touching, they are attached together, they are one term, and again, it means 5 times x. Next, we're looking for coefficients. Coefficients are any numbers that come in front of a variable that are attached to a variable. Remember, it means they're multiplied by a variable. Well, our only variable is x, and yes, it does have a number in front of it, touching it, attached to it. That number is 5. So our coefficient is 5. That means whatever x is, 5 is being multiplied by that amount. And last but not least, we have constants. Remember, constants are terms, so I can look at my list of terms that have no variable at all. This term does have a variable, but this one does not. So 13 is our constant. Sometimes there are no constants, but in this case there is. Moving on to part B, again, identify terms first. Those are the pieces being added together. I see 3 building blocks being added together, so those are the 3 terms. So the first one is 2z squared. The second is y. The second is 3. You might notice in both cases when we listed the terms, it looks almost exactly like the original expression, but wherever there was a plus or an addition symbol, I changed it to a comma just to change it into a list. Next, I'm looking for coefficients. Coefficients are the numbers that are attached to and are in front of a variable. So my first variable I see is z. In front of that, there is a 2. That is one of the coefficients. We have another variable, we have y, but you might be saying, there's no number in front of that. I'm confused. How is there a coefficient? There is a number in front of it. It's just invisible. What number can you multiply anything by, and it will just remain the same? Like you could take this number and you can multiply it by 10, you'll get 10. You can multiply it by 100, you'll get 100. That would be the number 1. If I put a 1 right in front of the y, 1 times y would still just equal y. So if there is no coefficient, or seemingly no coefficient, we don't see one, that means there is an invisible number 1. An invisible 1, because 1 times that variable is still just that variable. 1 times y is still y. And last but not least, constants. Remember, constants are terms with no variable, so look through your terms. The only one I see with no variable is the number 3, so that is our constant 3. Terms are the pieces that are added together. Coefficients are the numbers that come in front of a variable, that are attached to it, that are multiplied by it. And then constants are terms with no variable at all. All right, example 2, write each expression using exponents. Remember, exponents are the little baby numbers. They tell us if I have something that is repeatedly multiplied together, I can rewrite it using an exponent. So here I have the variable d represents an unknown number multiplied 4 times. That can be written as d to the power of 4, or d to the 4th power, because there are 4 variables of the letter d being multiplied together. Now, the next one looks a little different because not only do I have multiple h's multiplied together, I also have a number in front of that. Well, the only piece I can rewrite using an exponent are repeated multiplication. So I'm going to focus on just the repeated multiplication, h times h, which is h to the power of 3, h cubed. I can't forget that 1.5, though. That is still being multiplied by this. So I'm going to put 1.5 in front of it. And you could put times h to the 3rd power, but remember, we learned when a number is touching a variable, is right in front of it, there's no symbol, it's called its coefficient, and it means they're multiplied. So there is no reason to put a multiplication symbol, because this means that 1.5 is being multiplied by h to the 3rd power by 3 h's. Our last section says to evaluate an algebraic expression, substitute a number for each variable. So you know how when there's a substitute teacher, your teacher is gone, but then someone comes in their place? That means we're going to take out the variable and put a number in its place. We will be told what number to use. Then use the order of operations, remember that's GEMDAS, to find the value of the numerical expression. So example 3, evaluate 4n when n equals 12. So they're saying take out n, put 12 in its place. So I have 4n. The 4 gets left alone, but I'm going to take out the n and put 12 in its place. Now, the reason I'm putting it in parentheses is because we need to remember that 4n means 4 times n, right? 4n means the same thing as 4 times n. So I could write 4 times 12, or like this, 4 parenthesis 12. We got to remember that means they're multiplied. It is not 412. It is 4n, 4 times n, 4 times 12. 4 times 12 is 48. So there we go. We've evaluated it. I took n out, I put 12 in, figured out what it would equal. It equals 48. That is the value of this expression when n equals 12. Next one, evaluate a over b when a equals 16 and b equals 2/3. So this time I have 2 variables, a and b. I'm going to take both a and b out, put the numbers in their places instead. So I'm going to take a out and replace it with 16, take b out and replace it with 2/3. Oh my goodness, what does this mean? Well, a fraction bar represents division, so this is just a different way to say 16 divided by 2/3. When you divide fractions, you keep, change, flip. You keep 16 the same, change to multiplication, flip the second fraction. Except I am going to give 16 a denominator of 1. So I took my variables out, I put the values in, and now I'm evaluating it. I'm seeing what it actually equals. I could cross-cancel the 16 and the 2 by dividing both by 2. 16 divided by 2 is 8. 2 divided by 2 is 1. If I multiply the numerators, 8 times 3, I get 24. And the denominators, 1 times 1 is 1. 24 over 1 is 24. So the value of this expression, when a is 16 and b is 2/3, is 24. So I took variables out, put the values in, and I determined what it would equal. Example 5, evaluate 3x minus 14 when x equals 5. So again, we're going to take x out. We're going to put 5 in. So 3 instead of x, I'm putting 5. But remember to either write times 5 or put it in parentheses, because 3x means 3 times x, and x is 5. 3 times 5 minus 14. Now this is where we got to remember GEMDAS. In GEMDAS, multiplication comes before subtraction. So I'm going to do 3 times 5 first. I get 15. Then I do 15 minus 14, and I get 1. So the value of this expression when x equals 5 is 1. And last but not least, example 6, evaluate n squared plus 8.5 when n equals 2. Again, we're going to take n out and put 2 in its place. So instead of writing n squared, I'm going to write 2 squared plus 8.5. Again, we have to remember GEMDAS. According to GEMDAS, exponents comes before addition. So 2 squared means 2 times 2, which is 4. And then 4 plus 8.5, think about this 0.5 as being like 50 cents. $4 plus $8 is $12, and I still have 50 cents, 12.5. So the value of this expression when n equals 2 is 12.5.